Hello, Accelerated Chemistry students. This is Ms. Chrysofolia, and this is your Chapter 2, Section 4 video all over chemical reactions. So before we talk about chemical reactions, let's talk about what a chemical property is. A chemical property is the ability of a substance to undergo a specific chemical change, and that can be used to identify a substance. And it can only be observed when a substance undergoes a chemical change. So a chemical change is when the composition of the matter always changes. So in essence, a new substance is made. So examples would be burn, rot, rust, decompose, ferment, and explode, or corrode. Those are all the words that we use to describe that a chemical change has occurred. Now, a chemical reaction is when one or more substances changes into one or more new substances. And so you always are going to have a substance present at the start of the reaction, and that's called a reactant. And then the substance that is produced is what we are going to call the product. Now, if we were to look at this reaction, this you might have seen over the summer, if you light a fire or if you made something on the grill and used a coal burning grill, you have coal, you lit it on fire, and so it reacted with the oxygen and it made carbon dioxide. So if we were to write this in an element symbol form, it would be carbon as a C, which is solid, plus O2, which is a diatomic element, and it's oxygen, that's as a gas, and it makes carbon dioxide, which is CO2, and that is a gas as well. In this reaction, we have two reactants and one product. Two things are combining to make one thing. Now, how can we recognize chemical changes? There are 4 clues that can lead to us understanding if a chemical change has occurred. The first is the transfer of energy. The second is a change in color, the production of a gas, and the fourth and final one is the formation of a precipitate. Let's talk about these more in detail. So the first one we said was transfer of energy. So every chemical change involves a transfer of energy. So if we were to look at this picture, we first put on a raw piece of burger or a raw piece of beef. And so the propane in the tank was lit on fire. So that is releasing heat in a combustion reaction. That heat is transferring to the burger and is cooking the raw burger beef to make our burger cooked. That would be an example that a chemical change is happening. The next one would be color change. So when you mix two substances together and the product has a color to it that is different from what you started off with. So if we look at these two test tubes, the test tube on the left has a yellow liquid in it and the test tube on the right has a colorless liquid. And so when we mix those two together, the colorless liquid and the yellow liquid started turning into a reddish color. That would also indicate that a chemical change has happened. The next one would be production of a gas. So when you mix two substances together and bubbles forms, that's an automatic identifier that a chemical change has happened. So in the picture on the left, we have two liquids that we mix together, and you can see there's bubbles in the final test tube. And in the one on the right, we have a liquid and a solid. When we mix those together, bubbles are also forming. So that also is a clue that a chemical change could happen. And then the final one is the formation of a precipitate. A precipitate is a solid that forms and will eventually settle out in the bottom of the mixture if you let the mixture sit undisturbed for a long period of time. So if we were to take two liquids in the test tubes on the left, mix them together, that cloudy white thing that you see floating around in the final test tube, that is your precipitate. If you let that sit, it would actually settle down on the bottom of the test tube. And in the picture on the right, you have a liquid and a solid. Again, if you mix those two things together, you could also form a precipitate. Now, those are the 4 ways that we can determine whether or not a chemical change has occurred. Now, you can observe these clues, but that doesn't mean that a chemical change actually has taken place. Remember, they're clues. The biggest thing that you could be looking at is maybe a chemical change, but it could also be a physical change. So, for example, when you boil water, you make bubbles. but the water did not change. The composition is still the same. You had water as a liquid and you heated it up, and those bubbles that you were forming was actually the water vapor. So in order to determine whether or not a chemical change has occurred, you need to check the composition of the matter before and after the reaction or the change happened in order to determine that a chemical change actually occurred. And another thing that we see when we look at chemical changes is the conservation of mass. So during any chemical reaction, the mass of the products is always equal to the mass of the reactants. So mass holds constant during any physical changes, as well as in chemical changes. So for example, if I were to take 10 grams of ice and I were to melt it, I would make 10 grams of liquid water as well. So what does that look like? If we were to look at the conservation of mass, we talk about it as the scientific law, and it's the law of conservation of mass. So that states that during any physical change or chemical reaction, mass is conserved. So mass is also neither created nor destroyed. That is basically, in a nutshell, the law of conservation of mass. So how does that look like in an example? So the mass of your reactants is going to equal the mass of your products. So let's look at this. So if we have water, H2O, decomposing into the two elements that make it up. Now the 2's in front of the water and the 2's in front of the H2 gas on the right-hand side, we use that to balance our equation. And we're going to talk about that in later chapters. But if we were to look at the mass of this versus the mass of our oxygens, we should be able to add up and be the same thing. And we do. So we have 36 grams of water on the left, and then we have 4 grams of hydrogen on the right, plus 32 grams of oxygen on the right. Those add up to be 36. So we have the same mass of both the reactants and the products. So the law of conservation of mass holds true. Well, this is the end of your Chapter 2, Section 4 video notes. And as always, all of the information on these Google Slides has been acquired and adapted from Pearson Chemistry's 2012 edition of the Textbook Resources CD and pearsonchem.com. Thank you.